Hello and welcome to 10-5 Notes, where today we're going to be learning a new formula called the distance formula. But before we start the distance formula, let's just review some basic algebra skills. Back at the beginning of pre-algebra, I gave you this little mnemonic. It's a little lady and a gentleman, where we always said ladies come first when we are graphing our x and y coordinates of a point. So for example A, the first point we need to plot is M, and the coordinates of M are 8, so that means on the x-axis I'm going to move 8, and the y is 4, so I'm going to go on the y-axis, I move up 4. So 8 over, and then y is up and down, so 8, 4, positive 8, positive 4. Here are the coordinates and the location of M. For N, I need to move negative. Negative 6, x goes first, ladies first, and then negative 2. So on my y, which is up and down, I also went negative. So it's a negative 6 and a negative 2. And those are the coordinates of the point we are calling N. Now, the actual instructions say to find the distance between M and N. So to find the distance, I really can't count the boxes because I'm moving at a diagonal and I'm not cutting through each box evenly. So let me show you what you may already be thinking. We can do what we've just learned, the Pythagorean theorem, to find the length of MN. Because if I draw these two lines, I have formed a right triangle. Do we know how long this leg of the triangle is? Well, in elementary school we would have counted the boxes. But now that we're in pre-algebra, we know that we moved from 0, we moved over negative 6 spaces. And then to plot the M point, we moved over positive 8 spaces. To figure out the length of this leg, we from 0 on the y-axis, I moved down 2 spaces, and I moved up 4 spaces, making the length of this leg a total of 14, making the length of this leg a total of 6. So now we can use Pythagorean theorem to find the length of our hypotenuse, which we always call that C. So we're looking for MN, which is now the hypotenuse of this new right triangle that I have made. So here we go. 6 squared plus 14 squared equals C, which is what I'm looking for, squared. 14 squared is 6 squared is 36. I'm getting ahead of myself. 36 plus 196 equals C squared. So that's a total of 232 equals C squared. Now I'm going to take the square root of both sides, and C equals, and the square root of 232 is actually approximately 15.2. So now I found the length, or the distance between M and N, and that distance is approximately 15.2. Now, I'd love for you to try B. If you would pause the video and try to do B without me, that would be awesome. So pause right here. I'm afraid I know you too well, and you probably did not pause it, so I'm going to go ahead and work it out. Moving 5 positive and negative 6. Then I'm going to go positive 1, positive 2, and I'm looking for the distance between F and G. So you can make a right triangle here, or some of you may have made your right triangle at the top. Either way, it's still going to form this two congruent right triangles, but I'm going to stick to my blue triangle that I originally made. So again, I moved up 2 and down 6, so that made that 8, and I moved over, for G I moved over 5 spaces, but for F I'd already moved over 1, leaving us a length of 4. So 8 squared plus 4 squared is going to give us our hypotenuse that we're looking for, C. So 64 plus 16 gives us 80. So when I take the square root of both sides, C is approximately 8.9 units. We don't actually know. Okay, so as you look down your page, you will see the distance formula. And here it is. It's very intimidating. But let me show you, just for the sake of your knowledge, where they get this big, ugly formula. We had 2 points to start out with. The first point, we don't know what they are, but we'll just call them x1, y1. Then we had another point. Again, I don't know what they are, so I'll just call them x2, y2, standing for the second point, 1 standing for the first point. And they asked us, how far is it between them? The first example, it was M and N. Our second example, it was F and G. It doesn't matter what you name the points. We're looking for the distance between 2 points. And what we did is we turned that line segment into a right triangle. And we said, well, we can figure out how far we traveled on the x-axis, and we found that distance by subtracting x sub 2 minus x sub 1. And then we found out how far did we travel on the y-axis, and we find that distance by saying y sub 2 minus y sub 1. Now, we really didn't subtract them. We said we traveled -6, we traveled +8, but if you check it, -6 minus 8 would give us a -14. We already know that we're talking about length, and length cannot be negative. And if you forgot that length can't be negative, well, the next thing you're going to do to find D, the distance, is you're going to plug it into the Pythagorean theorem, where this is our A, this represents our B, and our C is D. So we have A, B, and C. So when we plug it into the Pythagorean theorem that says A squared plus B squared equals C squared, we actually have for A, x sub 2 minus x sub 1, and that's what we're going to square, plus y sub 2 minus y sub 1, that was our B, which we're going to square. So again, if you had them negative and you square them, they're going to turn positive. And that's going to equal our C, but in this case, we're actually looking for D squared. So if I'm solving for D, my distance, to unsquare D, I have to take the square root of both sides. And ladies and gentlemen, that is the distance formula. We've just derived, that's a big word for figured out where the distance formula came from. Alright, so example 2 says to find the distance between the 2 points using the distance formula. So let's write down our formula. I'm going to subtract my x's and then square that result, plus subtract my y's and square that result. And looking at my 2 points, this is my x and y sub 1, and this will be my x and y sub 2. In other words, my first point and my second point. So plugging in x sub 2 here is 9, minus x sub 1 right here is 1. I'm going to square that, plus y sub 2 was 5, minus y sub 1, which is also 5. So I'm finishing out the formula. Subtract those, you end up with 8 squared, plus subtract here, and you end up with 0 squared. So we're actually taking the square root of 64, which goes back to give us 8. So our distance between G and H, the distance of GH, is 8. And again, you would just say units because we do not actually know if it's inches or feet or meters or millimeters. So the distance between G and H is 8. Example 3 says to classify triangle XYZ. So let's look over here at triangle XYZ. And I'm classifying it by its sides. Now my choices are no sides are equal, that's called scaling. 2 sides are equal, that's called isosceles. or all three sides are equal, and that's called equilateral. So those are my three choices, but I do not actually know the lengths of my sides. So besides classifying it, it also wants us to find the perimeter to the nearest tenth. So that means I've got my work cut out for me. So let's roll up our sleeves. I'm going to need to find this distance, and the third distance. So I'm just going to call them D1, D2, D3. So D1, my distance for my first set of points, is going to be, and again, let's rewrite the formula just so we have it in front of us. The distance formula is the square root of your x's subtracted, then squared, your y's subtracted, then squared. So back to blue, D1 equals, my x's for D1 are -3 and -2. So -3 minus -2, beware of that minus and negative right there, plus my y's, which is 1 and 8. So 1 minus 8. So distance number 1 is going to be, two negatives make positive. So that's a -1 squared plus a -7 squared. And that's going to give me 1 plus 49. The square root of 50 is approximately 7.1. And then I had to estimate. And it said to the nearest tenth. So distance number 2 is going to be here. I'm looking over here at these 2 points. So my x's are -2. It does not matter which one you put first. -2 minus 3 squared plus 8 minus 3 squared. So distance number 2 is going to give me a -5 squared plus +5 squared. So that's going to give me +25 plus 25, the square root of 50 again. And that's about 7.1 again. And then last, let's pick a new color. How about purple? For distance number 3, I'm running a little short on space. Let's put distance number 3 down here. Again, I'm looking at this side, so I'm comparing these points. My x's are -3 and +3. My y's are 1 and 3. Alright, so we're going to end up taking the square root of -6 squared, -6, plus -2 squared. When you square a negative, it becomes positive, so that's going to be the square root of 36 plus 4. For the sake of space, I'll just keep going horizontally, so that's the square root of 40, which is approximately 6.3. Alright, so now what was this question asking me? Let's go back. We're supposed to find the perimeter to the nearest tenth. Alright, let's find perimeter. Perimeter equals all the sides added together. Oh, I have two sides that are the same. Remember that for the next question. So when you add those up, our perimeter is approximately, because these were all estimations, 20.5. So there's our perimeter, 20.5. And then it also asked us to say whether it was scalene, isosceles, or equilateral. Since I have two the same, it is isosceles. Alright, feel free to rewind and watch me work through that problem one more time. We'll be practicing the distance formula the next couple of days. Thank you and have a great day.